Hi everyone, welcome to Pre-Cal. I hope you watched the Welcome to Pre-Cal video first. This is our first day's worth of content. It's light because the first day back is usually hard for people, so I intentionally made it gentle and light. There is a homework for this, and you can find the scanned pages in our Office 365 team to do that homework assignment. But we start off gently with a conversation reminding us about slope. Remember, when we talk about the slope of a line, we're talking in terms of rise over run, and we can think of that as a change in y values over a change in x values. Now, in calculus notation, we might say that's delta y over delta x, a change in y's over a change in x's. But you probably learned in middle school, or at least in Algebra 1, y2 minus y1 over x2 minus x1. And of course, this works as well. What's important is that the ordered pairs are over each other and that y values are on top, okay? So that's the way we find the slope. So let's take some ordered pairs like 0, 3, and 5, negative 2. Here's two ordered pairs. And I want to know the slope between those two lines, between those 2 points. So I'm going to use my slope formula. I'm going to say 3 minus a minus 2 over 0 minus 5. And I get 5 over negative 5, which is negative 1. Notice I made this ordered pair go first. Well, let's do it the other way. Let's do negative 2 minus 3 over 5 minus 0. And look, when I do it this way, I get negative 5 over 5, which is still negative 1. We get the same slope either way. Okay, so with these next problems, I'd like you to pause the video and see what you can get, and then turn the video back on and compare with my answer. So here's the next ordered pair, negative 2, 5, and negative 3, 1. Okay, pause the video and try this. Find the slope between these 2 points. And when you're done, unpause the video and see if you were correct. Okay. Minus 5 over negative 3 minus a minus 2 is negative 4 over negative 1, which is positive 4. Okay, so I got positive 4 as my slope here. Watch out, this is a minus 2 that I'm subtracting, so minus a minus is plus 2. Negative 3 plus 2 is negative 1. Okay, how about this one? Let's see. 4, 0, and 4, 3. Please find the slope here, pause the video, come back when you're done. Okay, welcome back. So I got 3 minus 0 over 4 minus 4, which is 3 over 0. 3 over 0 is not 0. This is undefined. Undefined. Think of it this way. This is the number of pizzas sitting on the dining room table. This is how many people come into the dining room to eat pizza. So how much pizza per person? Well, that's undefined because there's no people there. If we have a 0 on the bottom, that's undefined, okay? 0 on the bottom means undefined. All right, so how about this last one? D, 1, 5, and negative 2, 5. Why don't you try and find the slope between these 2 ordered pairs, and pause the video while you do that, and then come back and check your answer. Okay, so I would do 5 minus 5 over negative 2 minus 1, which is 0 over negative 3. There are no pizzas divided by 3 people. You don't get any pizzas. So a 0 on top means 0. When we have a 0 on the bottom, that means undefined. And think about what these slopes look like if we think about graphing them. This one, here's negative 2, 5. Here's 1, 5. This is a horizontal line. And I have a 0 slope for a horizontal line. But the problem before that, C, that we did, had 4, 0 and 4, 3. And when we did this, we got a 0 in the denominator, and we said that was an undefined slope. And so a vertical line has an undefined slope. Okay. Next, let's talk about average rate of change. Average rate of change is something that comes up in our class and is terribly important for those of you going on to calculus. Average rate of change for us can be thought of as slope with units. Slope with units. It's a change in the output with respect to a change in the input. Okay, so let's imagine, and that's, just our slope formula, right? y2 minus y1 over x2 minus x1. Well, what happens if we have a function like this? Position as a function of time is 4 minus t squared. And I'd like to know where t is time in seconds and s is height. Okay, in meters. Now, when I think about average rate of change and I think about slope, I have a problem because I don't have any x's and y's. I could certainly find the slope, find the average rate of change on 0 to 1. This is interval notation. It means start at time equal to 0 and end at time equal to 1. So how could I figure out the average rate of change here? Well, I'm looking for a slope between 2 points. One of those ordered pairs starts with 0, and the other ordered pair starts with 1. I have the 2 inputs. I just need to find the outputs. So to find the outputs, I'm going to take a 0 and plug it in for t, because this is a t value and I'm looking for an s value. If I plug in a 0 here, I get 4. And again, over here, I've got a t value of 1. I'm looking for the s value. If I plug in a 1 here, 1 squared is 1. 4 minus 1 is 3. So even though I'm thinking about a parabola here, not that parabola, though. It's a down-pointing parabola. There's our parabola, which has the point 0, 4 and 1, 3 on it. I'm actually looking for the slope between those 2 points. I'm looking for the slope between those 2 points. So in order to do that, I just use the slope formula between these 2 ordered pairs. Remember, average rate of change is slope with units. So let's think about our slope formula now with these 2 ordered pairs, 0, 4, 1, 3, and we've got 4 minus 3 over 0 minus 1, which is 1 over negative 1, or negative 1. That's a slope, but it's not got any units attached to it. Remember, we said that the units on our input were seconds, and our units on the output were height in meters. So our output units are meters, and our input units down here are seconds. And so if I'm thinking about the average rate of change, it's -1 meters on top and seconds on the bottom. -1 meter per second. Sometimes I find it useful to use this fractiony form as a way of applying the units. But when I see it here, for a lot of students, it doesn't make sense to say I go up 1 unit for every -1 second. Yeah, remember, your 7th grade math teacher tried very hard to get you to understand that this was the same as this was the same as this. And so while this might not make a lot of sense in our context, and this feels hard for me to develop that concept of meters per second because I don't have a denominator, this version works really well. -1 meter per second. So we've got a lot of things going on with this average rate of change question. First, we remember that average rate of change is slope with units. So we need to use the slope formula. But I only had the starting time and ending time. Remember, we had to plug those values into our s of t function. I had to plug in this t value of 0 to get an s value of 4. I had to plug in this t value of 1 to get an s value of 3. Once I had the two ordered pairs, no problem using the slope formula. But then, when I was all done, I had to remember that average rate of change is slope with units, and so I needed to go back and remind myself that the units on top are the outputs, those units are meters, and the units for the bottom on the inputs were seconds. So I had meters per second. Okay, now, why don't you practice one? Where you find the average rate of change on the interval from 0 to 2. Remember, we're still using the same s of t, 4 minus t squared. You could use any function to find the average rate of change on. I just want to keep it simple right now and use the same formula we did last time. Okay, find the average rate of change on 0 to 2 using this position function. Pause the video, give it a try, come back when you're done. Okay, how'd that go? Were you able to find the value, or did you get stuck right away? Remember, I need to find the two ordered pairs. So s of 0 is 4, and s of 2 is 0. So I can write these two ordered pairs, 0, 4, and 2, 0. Now let's use the slope formula to find that average rate of change. 4 minus 0 over 0 minus 2, 4 over -2, or -2. Now remember, we've got to have units. The units on our outputs are meters, the units on our inputs are seconds, so this is meters on top and seconds on the bottom. When changing, the height is changing, going down 2 meters for every second we travel. Now that's different from the first average rate of change, isn't it? Well, let's take a look at this graphically again. Here's our parabola, and we said we would have 0, 4, and 1, 3. And originally, we said that was a slope of -1. That means we went down 1 meter for every second we traveled. But now we're looking at the interval from 0 to 2. From 0 to 2. And from 0 to 2, we see that this slope is much more steeply negative. So we found n here to be -2. We know that this went down 2 meters per second. So we were at 4, we went down 2 over 1, down 2 over 1. Notice average rate of change is always on an interval. It's not instantaneous rate of change. That's slope at a point, and we'll talk about that in calculus. But for us, we're looking for slope on an interval. Let's try one more of those. Our function, again, s of t equals 4 minus t squared. But this time, how about on the interval from 1 to 2? Why don't you pause the video now and find the average rate of change on 1 to 2. Okay, welcome back. I hope that went a little easier for you. I need s of 2, and I need s of 1. And so now I've got these ordered pairs, 1, 3, 2, 0, and I can use my slope formula. 3 minus 0 over 1 minus 2 is 3 over negative 1. Or negative 3, don't forget the units, meters per second. That's even steeper than it was from 0 to 2. Well, let's go back and look at that graphically and see why that makes sense. So, you have this parabola, and we're looking at the points 1, 3, 2, 0, and 0, 4. We said that the slope here was negative 1. And we said that the slope here, straight, was negative 2. And now we just found this slope here. And notice that this slope is more steeply negative than either of those. So it doesn't surprise me that that slope turns out to be negative 3. Okay, so average rate of change is just slope with units. What else do we need to talk about today? Well, let's talk about equations of lines. You've been doing equations of lines for a long time now. But we just need you to be really comfortable with this information. There are two forms that we use to make the equation. Those two forms are slope-intercept form and point-slope form. Many of you are probably prefer using this one. I actually prefer using this, and all my calculus students only use this one. So let's take a look at them. They're y equals mx plus b, and y minus y sub 1 equals mx minus x sub 1. I really do need you to know both of these, and I need you to pay attention to the directions on homework or on quizzes and tests. If you see use slope-intercept form, then I need to see you using slope-intercept form. If the directions say use point-slope form and you use slope-intercept form, I have to mark that wrong because I'm actually testing you on using point-slope form. So please make sure you read the directions carefully for the problems that you do. Now, why are these forms called what they're called? Well, this form is called slope-intercept form because I need to know the slope of the line and I need to know the y-intercept. The y-intercept is where this line crosses the y-axis. With point-slope form, I need an ordered pair, a point, x1, y1, and I need a slope. So that's what I need for either of these. Well, let's see about writing the equation of a line with each of these forms. Okay, we've got ordered pair 3, 2, another ordered pair 7, negative 4. Let's start with slope-intercept form. So in order to use slope-intercept form, I need a slope. So let's start by finding the slope. We just practiced that. 2 minus a minus 4 over 3 minus 7. I get 6. I get negative 4. I get negative 3/2 when I reduce. Now, I don't have a y-intercept. So even though I want to use y equals mx plus b, and I can plug in for m, this slope that I just found, I don't know this y-intercept yet. So I'm going to have to use one of these ordered pairs. It doesn't matter whichever looks less scary to you. This is the one I'm going to use because it doesn't use the negative number. And I'm going to plug in for x and y. So 2 equals negative 3/2 times 3 plus b. Okay, well, I can certainly determine that 2 equals negative 9/2 plus b, but I'm trying to solve for b. So I had better add that 9/2 to both sides. I'm going to add 9/2 to both sides. Now, in order to add a fraction to something that's not a fraction, I'm going to need to make a common denominator. Common denominator is halves, so 2 over 1 times 2 over 2 is 4/2. So I'm thinking about adding 2, which is 4/2, to 9/2 to get 13/2. Over here, these cancel, and I'm left with b equals 13/2. Okay, so now I'm ready to write the equation of my line. I have a slope, I have a b value, so I can say y equals negative 3/2 x plus 13/2. Now, how do I know if this is the correct line or not? Well, if I plug in my ordered pair for x and y, I should end up with this side equaling this side. Let's give that a try and see what happens. Okay? I'm going to plug in the other ordered pair, 7, negative 4, and see if it works. Negative 4 equals negative 3/2 times 7 plus 13/2. It's a 13/2. Okay, so that's negative 4 equals negative 21/2 plus 13/2. Negative 4 equals, negative 21 plus 13 is negative 8 over 2. And negative 8 over 2 is negative 4. So lo and behold, negative 4 equals negative 4. This must be the equation of my line. That's in slope-intercept form. I used slope-intercept form to write the equation of this line. And I'm also displaying the answer in slope-intercept form. We have two forms to display our answers. One of them is slope-intercept form. We just showed y equals negative 3/2 x plus 13/2. But the other one is called standard form. And standard form looks like this: ax plus by equals c. Notice in standard form, the x and y's are on the same side. That's not true in slope-intercept form. So I want to take my answer and write it in standard form. Make sure you pay attention to the directions on the questions. If it says write your answer in standard form and you give me slope-intercept form, I have to mark that wrong. Okay? If it says standard form, I need the answer in standard form. So standard form has the variables on the same side. That means I have to add 3/2 x to both sides. So I'm going to have 3/2 x plus y equals, and our c value, 13/2. Now, for me, this would be sufficient, but there are some math purists, you might call them old fuddy-duddies, who say that these a's and b's can't be fractions. So I'm going to have to multiply here to clear out the fraction. I'm going to multiply here by 2, and here by 2, and here by 2. When I do that, I get 3x plus 2y equals 13. This is the same line as y equals negative 3 halves x plus 13 halves. There's standard form, there's slope-intercept form. Okay, and I need to be comfortable with displaying my answer in both of those forms. But remember, we also said that we need to be able to write our equations of lines not just with slope-intercept form, y equals mx plus b, but also y minus y sub 1 equals m times x minus x sub 1. Remember, this one was called point slope form. In order to make this form work, I need an ordered pair like 3, 2, and I need a slope. We found the slope here to be negative 3 halves. So let's take the ordered pair and plug it in for x1 and y1, and let's plug in our slope. So y minus 2 equals negative 3 halves, x minus 3. Okay, so this is using point slope form. Now let's display our answer in slope-intercept form and display our answer in standard form. Okay, so I'm going to distribute on the right-hand side and have y minus 2 equals negative 3 halves x. Minus times minus is plus. And then I'm going to add 2 to both sides. Remember, in order to add a fraction to something that's not a fraction, I need to make a common denominator. We found out that that was the same as adding 4 halves. And so lo and behold, here we are with y equals negative 3 halves x plus 9 halves plus 4 halves, or y equals negative 3 halves x plus 13 halves, just like we did with slope-intercept form. Again, you might be saying, Mr. Kukla, I can do that with slope-intercept form. Why do I need to use point-slope form? Well, like I said a few minutes ago, in calculus, I don't use slope-intercept form. I only use point-slope form. So I really want those of you who are going to be taking another math class to make sure that you're comfortable with slope-intercept form. Yes, but also point-slope form. Okay? All right, why don't you try using point slope form, write the equation of the line through the points negative 1, negative 2, and negative 5, 3. Display your answer in standard form. Okay, why don't you pause the video and give that one a try, and come back after you think you have it or when you get stuck. All right, so we're told here to use point slope form. So that means I'm going to need to find a slope. My slope will be 3 minus a minus 2 over negative 5 minus a minus 1. That's going to be 5 over negative 5 plus 1 is negative 4. So there's my slope. I'm using point slope form. So here's a point, here's the slope. I've got y minus a minus 2 equals negative 5/4 x minus a minus 1. Well, I think I want to tidy that up a bit. Y plus 2 equals negative 5/4 x plus 1. And that's great, but that's not yet in standard form. So let's take this a little further and move it to standard form. We've got y plus 2 equals, over here I'm going to distribute and have negative 5/4 x minus 5/4. Now I need to subtract 2 from both sides. I get y equals negative 5/4 x. Remember, I need a common denominator, so that's 8/4 and 5/4. which is minus 13/4. And this is slope-intercept form, but we were directed to write our answer, display our answer in standard form. So remember, I need to get the x's and y's on the same side. Let's add 5/4 x to both sides. And so now we'll have 5/4 x plus y equals negative 13/4. Now, on a test or quiz in our class, I would accept this as being in standard form, but you know, I bet the U of A math placement test won't, because that was written by a bunch of old fuddy-duddies who say, no fractions here, so I need to multiply everywhere by that denominator to get 5x plus 4y equals negative 13. And there's our answer in standard form. Okay, I hope that was a useful review of the equations of lines. Let's just summarize. We've got two ways to write the equation, to make the equation, and make the equation of a line with slope-intercept form. Y equals mx plus b, or point slope form, that's y minus y sub 1 equals mx minus x sub 1. And then I display my answer in slope-intercept form, or standard form. Remember, standard form has the x's and y's, x's and y's on the same side. Okay, so last thing I want to talk to you about today are special lines. When we see y equals a number, like y equals 3, y equals negative 2, that makes a certain type of special line. So y equals 3 has these ordered pairs, negative 1, 3, 0, 3, 1, 3. What kind of line do I get when I graph those points? Negative 1, 3, 0, 3, 1, 3. I get a horizontal line with a slope of 0. So whenever I see y equals a number, that's going to make a horizontal line. And we know that a horizontal line has a slope of 0. That's one of our special lines, y equals a number. And sometimes you'll see that written in this manner, y equals b, where b is any number. Well, what if instead of y equals a number, we've got x equals a number, like x equals 2 or x equals negative 3? Well, when I make this t-chart, no matter what y value I think about, the x value is petulantly always saying 2, 2, 2. And if I graph this, here's 2, 1, here's 2, 0, here's 2, negative 1. And I end up with, lo and behold, a vertical line. So when we see x equals a number, that's going to be a vertical line. And we said a little while ago in this video that a vertical line has an undefined slope, okay? I can't write this in slope-intercept form. The only way I can write this equation is x equals a number. X equals a number is telling me, oh, you're talking about a vertical line. Y equals a number, I've got a horizontal line. Okay, so we've got a lot of things going on here. We've got slope, we've got average rate of change. Remember, that's slope with units. We've got writing the equations of lines using slope-intercept form or point-slope form, and displaying our equations of lines using standard form or slope-intercept form. And then finally, we talked about special lines, namely vertical line x equals a number, and a horizontal line y equals a number. All right, why don't you try this one? I've got some ordered pairs here. 1, 4, B is negative 2, 4, and C is negative 2, 5. All right, I'd like to write the equation of line AB. Please write the equation of line AB. So, if I write the equation of line AB, I need slope, because whether I'm using slope-intercept form or point-slope form, both of those forms require a slope. Okay, here we go. We've got 4 minus 4 over 1 minus a minus 2. That's 0 over 3. Remember, 0 on top is 0. Uh-oh, my slope is 0. What kind of line has a 0 slope again? The kind of line has a 0 slope is y equals a number. What number? They both have it. Y equals 4 is the equation of this line. Okay, so notice I didn't really use slope-intercept form or point-slope form here, right? I just used the fact that my slope was 0. That means I have a horizontal line, which is y equals a number. Let's try writing the equation of the line segment BC. Okay, the line segment BC. We're going to use these ordered pairs now. Again, the first thing I need to do is find the slope. 5 minus 4 over negative 2 minus a negative 2. I get 1 over 0. Uh-oh, 0 in the denominator. That's an undefined slope. What kind of line had an undefined slope? Remember, x equals a number. X equals a number is the equation of the line with an undefined slope. What number? Well, look, both of those x's have it. Negative 2. So the equation of the line segment BC is x equals negative 2. Okay, why don't you try this last one on your own? Please find the equation of AC. You can use either slope-intercept form or point-slope form, and I would like you to write your answer in standard form. Please write the standard form of the equation of the line from A to C. Pause the video now, give it a try. Come back when you have questions or when you want to check your answer. Welcome back, everyone. Remember, the first thing we need to do is find a slope. 5 minus 4 over negative 2 minus 1. I get 1 over negative 3 as my slope. I'm going to use point-slope form. So I've got y minus, and this ordered pair, y minus 4 equals negative 1/3 x minus 1. And we were asked to write our equation in standard form, so I'm going to have to distribute over here, move the x's over, and move this 4 over here. So let's do some of that stuff. Negative 1/3 x. Don't forget, negative times negative is positive 1/3. I want to move the x's over here with the y's. I want to get this number over here. So I'm going to add 4 to both sides, and I'm going to add 1/3 x to both sides. So when I'm all done, it should look like 1/3 x plus y equals 4 1/3. Or if you prefer, 13/3. That's fine for us. Again, if you're checking answers in the back of the book or on Slater, you're probably going to see x plus 3y equals 13 as our answer, because they multiplied everywhere by 3 to clear out that denominator. Well, I hope you're feeling comfortable with this review and that you're ready to tackle the homework. Assignment number 1 is your assignment tonight. It's reading pages 24 through 32 to review the material. I know most of you won't do that, but I'm going to say SWAR anyway. And SWAR, S-W-A-R, I see it here on the assignment calendar, stands for Students Will Actively Read. Not passively read, so you don't actually know what the words are as you buzz your eyes over them, but instead maybe you're even taking notes about this stuff. And then finally, here's our homework assignment. We're going to do on these pages these problems, and on this page, these problems. Okay, and notice parent required letter home. You need to ask your parents to go here and fill in a little questionnaire, answer the questions, and submit this. This actually counts, this right here counts as its separate homework assignment. So you've got 2 homeworks tonight, one for you and one for your folks. So will you please take care of that? And I'll see you in our next video, which seems to be dealing with equations of parallel and perpendicular lines and linear word problems. Don't worry, it'll be a piece of cake, and we've got a worksheet for that. All right, see you in the next video, or in our in-class Zoom. Take care, everybody.